Welcome to another edition of Comet Algebra. This video is for Algebra 2, Chapter 4, Section 5, Inverse Matrices and Solving Systems. So we'll start our discussion by talking about what this means right here, this a to the negative 1 power. This little negative 1 power indicates that it is the inverse of matrix A. And so a little discussion here. If you take a matrix A and you multiply it by its inverse, you get the identity matrix. If you take the inverse of matrix A and multiply it by matrix A, you get the identity. And I'm just going to ask you, do you remember what the identity matrix looks like? Well, if you don't, from our previous discussions, it is a matrix and it has to be a square matrix. So a 2 by 2, I'll just put a 3 by 3 here for our example. An identity for multiplying is when the major diagonal are 1s and every other element is 0. So this is what the 3 by 3 identity looks like. So just to repeat, if you multiply a matrix times its inverse, you end up with an identity. So this first example asks us, are matrix A and B are the inverses of one another? Well, what's the strategy? Back up here. If we multiply the two matrices and we end up with something that looks like this, except we have a 2 by 2 example here. So the 2 by 2 identity would look like this. So how we could tell is if we did A times B, looked at the answer, if it's an identity, we could say yes, they are inverses, and if it's not, we could say no. So multiplying A by B, remember we take this row times this column. So 4 times 3 halves is 12 halves, which is 6. And then we have negative 2 times 5 halves, which is negative 10 halves, which is minus 5. So we'll simplify this in a minute. For this next entry, we take this row times the second column. 4 times negative 1 is negative 4. Negative 2 times negative 2 is plus 4. Now for this bottom row, we take this row times the first column. 5 times 3 halves is 15 halves. And then negative 3 times 5 halves is negative 15 halves. And now for this last entry, we take the bottom row times this second column, which is negative 5 plus 6. So now let's simplify these elements. And 6 is 1, 0, 0, and 1. So we did get an identity. Therefore, we can answer the question, are they inverses? Certainly, yes. All right, this next statement here is a repeat of what we had put in our notes earlier, and it has lots of stars, so it must be important. You will be asked to determine if two matrices have an inverse, and to do so, you find the determinant. If the determinant is 0, you would have to say, no, there is no inverse. And if the determinant is any number, anything at all, then we would say, yes, it has an inverse. So I'm just asking you to put this in your notes again. Can't review it enough because people do seem to forget. Now, this next part is really just to show you. We are actually going to be finding inverse matrices on our calculators, but I want you to know what your calculator is doing. So let's just take a quick look at how do you find an inverse. Well, this formula is saying to find A inverse, you take 1 over its determinant, and see how A and D are the major diagonal? You actually switch places with them. So you pick up the A and move it down to this location. That is supposed to be an A. Wow, that's awesome. Good typing here. So I'm going to change that to A. So you switch those places, and then you negate the minor. So you put negative signs on the minor. And this kind of answers the question, why does a matrix not have an inverse if the determinant is 0? Well, look where this determinant is. You cannot, in our number system, divide by 0. So this can't happen. This whole calculation doesn't work if the determinant is 0. So that's kind of the why part of this statement we put up here with the stars. If the determinant is 0, it has no inverse because we cannot divide by 0 in our number system. So this is an example. I'm going to do it pencil and paper, finding the inverse. I guess this goes under the category of exposure. I want you to see this, but then we're actually going to use our calcs to find this. So I kind of listed the steps here. Find the determinant, and then we'll put 1 over the determinant. We switch the main diagonal, negate the minor diagonal, and then we'll simplify it. So first, let's find the determinant of this matrix. So if you recall, a determinant is the major product, subtract the minor product. So this major product is -4. The minor is -10, so we're subtracting a -10, which becomes adding. So the determinant is 6. So in the formula, we put 1 over the determinant on the outside of the matrix, so that'll become a scale factor. We, right here, step 2, switch the main diagonal. So this -4 bounces up here, and the 1 down there. Step 3, negate the minor. So in other words, you take the opposite. -2 is +2. +5 becomes -5. So now the last thing to do is just multiply everything in this matrix by the 1/6. So I'm going to try to reduce this at the same time. -4/6 reduces down to -2/3. -5/6 does not reduce at all. 2/6 reduces to 1/3, and that fraction is just 1/6. So this is the inverse of A. Now, doing the inverse of 3 by 3 is a nightmare, and we are not going to do that in this video, and we're going to be finding that inverse on our calculators. At this point in the lecture, when we're in class, we will stop and learn how to enter matrices on our calculators. Now, I really can't show you that in this video, so see me during class or before school or after school, and I'll show you how to enter these, because now we need to know how to enter matrices in order to do what's coming next in the lesson. This screen you're looking at right now is probably the most important notes of the whole chapter. So do write it down. It got lots of stars. It's really important. So when you see this equation, A and C are both matrices. So we have a matrix times x equals another matrix, and we need to solve for x. Now, in typical algebra, you would divide both sides by A, but we don't do that in matrices. We don't divide them. So what we do is left multiply by its inverse. This left multiply is huge. Remember, matrix multiplication is not commutative, so the order does matter. So if this is a matrix times x equals c, we're going to left multiply the A and the c by the inverse of A. And that's how you're going to solve for x. X is equal to the inverse of A times c. This is the key to solving matrix equations. Write this down, know this. And I will bug you a lot about left multiplying. So this is very, very important to write in your notes and understand it. So let's look at an example. So to solve for this x, I'm going to need to assume that you have already seen me and you know how to enter these on your calculator. You need to remember where you put different matrices. So this 2 by 2 matrix, I'm going to enter it in the A location, and this 2 by 1, we're going to enter it in the B location. And so now we need to multiply, left multiply by the inverse of A here and here. So when you enter this on your calculator, go ahead and enter this 2 by 2 in A, this 2 by 1 in B, and then you got to quit out of the matrix menu. And so from the home screen now, we need to go get matrix A. So hit matrix, and under names, just select matrix A, and it will bring this to your home screen. Now we don't want A, we want the inverse of A. So if you hit the inverse key, which looks like this, it's x to the negative 1, if you hit that key, your calc will add the inverse notation here to A. On your calcs, if it's an old one, you may need to enter a time sign, but the new ones do not. Now go back into the matrix menu and select matrix B so that you actually have this appearing on your home screen. You need to see this. And then if you hit enter, it should give you the matrix -3, 2. And what this is saying is this is solved for x. X is the matrix -3, 2. And then try it if you want to check your answer. This 2 by 2 times our answer would give us -2/0 in that matrix. So this is the last example. Now we are finally going to use matrices to solve systems of equations. So we learned earlier in the chapter how to write a matrix equation from the systems. So first we have the coefficient matrix, where you just pull out the x and y coefficients. And then we had an xy matrix equals the answer matrix. And again, it doesn't matter where you enter these, but you need to remember the location. So if we choose to enter this 2 by 2 in the A location and this 2 by 1 in the B location, enter those on your calc, quit out of the matrix menu, go back in and grab matrix A, hit the inverse button so that this appears on your home screen just like that, go back in and grab matrix B, and when you multiply those, you should get the answer matrix of 3, 2. And how you interpret this answer then, x is equal to 3 and y is equal to 2. All right, now you have all the knowledge you need for section 4.5, so have fun with math.